So, and I have the pleasure of interviewing two leading experts in the transition to a more sustainable society, and they're here with me in the studio in Stockholm. Valentin Monteiro, you're head of sustainability at Schneider Electric, and also with me Kajsa Ryttberg-Wallgren, and you are with H2 Green Steel, and there you are executive vice president of growth and hydrogen business. That's a great title. Congratulations, I would love to have that title too. So Valentin, you're head of sustainability at Schneider Electric in Sweden. So please tell us about Schneider Electric's role as an impact company.
Yes, thank you. So actually, you know, when we look a little bit at the context systemically and like all the crises we are going through, and especially like the climate crisis as one of them, in fact, we strongly believe that not only companies can be involved, but must be involved actually. So we summarize the concept of an impact company with 5 simple principles. The first one being performance, because that's the foundation to do good. The second one will be business, and to basically include sustainability in the core of what the company is doing thanks to innovation and technology. Then the third one will be about bringing ESG, raising the bar to bring ESG in the core of the company strategy and organization. The fourth point will be about bringing actually everyone along to this transformation. So basically from customers, employees, suppliers, and the entire society with it. And we kind of summarize it with saying, okay, you have to kind of do well to do good, and then do good to do well, and to bring everyone along. And if you think about this one, so as a concrete example, if we bring now, think about the carbon impact or the climate impact of Schneider Electric as a company, it's about 60 million tons of CO2, which is roughly equivalent to 0.1% of the total global greenhouse gases emission that we have yearly. And it's also equivalent to roughly the yearly emission of Sweden as a country. So that's for the footprint. But the climate impact, actually, of Schneider, if you take into account what we save and avoid at our customers thanks to the technology that are operating in all the applications that we are serving, we are actually having a positive impact of about 90 million tons of saved and avoided emissions. So roughly 90 minus 60, 30 million tons of CO2 already positive in terms of impact. And zooming into like the, let's say the actual footprint of Schneider, so this 60 million tons of CO2, less than 1% of it is really like the own operation of Schneider Electric. So then more than 99% is the rest of the ecosystem. 14%-ish is what we have at suppliers, so like all the supply chain, and we work actively with the supply chain. We have a specific program, with the top 1,000 suppliers of Schneider Electric to help them decarbonize by 50% their own operations by 2025, which we measure as part of the Schneider Sustainability Impact goals. And then the rest is more on the let's say the downstream side, so what we have with customers and so on and so forth.
This is quite impressive, indeed. So Kajsa, let's turn to you. In your own words, because I've heard you say this, steel is a quite big part of materials we use in society, of course, and we all know this. And being the EVP of business unit hydrogen at H2 Green Steel, what is your take on what you can achieve? And of course, we need to know a little bit more about what you're doing and your future plans to expand.
So basically, I think the starting point of this question is, why do we exist? What is the purpose of our existence? And it drills down to the Paris Accord. That's where it all started. That's where we agreed globally to stay below 1.5 degrees. If you want to do that, you need to address hard-to-abate sectors. One of the hardest to abate, so to say, is the steel industry. Today, the steel industry accounts for about 8% of global CO2 emissions. And that's emissions that you cannot directly electrify. So how can you do that? Then you need to understand where is the problem. Today, the majority is coming from a traditional steelmaking route, which is blast furnace. The blast furnace you use to produce iron, you basically need to take away the oxides or the oxygen from the iron ore that is coming from the mine, and in a blast furnace you use carbon to trigger that chemical reaction. That is the bad guy. That is what you need to address. And there is a mature technology available to address that specific challenge. It's another type of technology. It is a reactor where you can use hydrogen instead for the reaction of getting rid of the oxygen. If that hydrogen is produced using electrolysis and renewable energy, or at least fossil-free energy, you can take out about 95% of the CO2 emissions from steelmaking.
So that will be 95% out of the 8% global emissions.
So then you get into a deeper question, because that would assume that you can do that everywhere in the world, which you can't, because you need specific conditions for it. But for what we do, yes, we take out 95% of the CO2 emissions. And the challenge here was that back to the Paris Accord, the customers, they saw this, they committed to science-based targets, and they said, okay, where is the steel industry? Can you deliver this to us? We need to get rid of CO2s coming from embedded carbon. Nobody was there. And then we actually started. Our founders figure that the steel doesn't need another pilot. It needs large scale. And that's why we are building a steel mill that, when it's fully operational, will abate about 9 million tons CO2 per year. So that is, I would say, the reason for our existence. So our purpose is not to become the biggest steel company in the world, but it is to decarbonize hard-to-abate sectors. And we start with steel. We start with one plant in northern Sweden, and then we go from there.
Now, please tell us about your further expansion, because the first plant is in Sweden, and you have plans. You're going to work on other continents too?
That's correct. So the beauty of what we do is that we are greenfield. So instead of trying to retrofit steel assets that are located where it was successful to produce steel in the past, meaning you have close access to coal, to the customer, and things like that, natural gas, we can find the best power nodes in the world. So now, if we simplify a bit, when we are looking for new locations, it's a combination of three main areas. One is renewable energy, or at least fossil-free energy at the base load. That is crucial to make this work at huge volume as well, at a good price. So it's about the energy. The second part is access to good logistics for iron ore, and not just any iron ore, but the right quality of iron ore. And thirdly, the political support to make this happen. One part of that is, of course, how you get support in terms of permitting processes and things like that. But the other part is what kind of policy you have in place, for example, carbon pricing and subsidies and things like that. These three areas is pointing us in different directions, and we do see that the best places to do that, if you look in Europe, is northern Sweden, and we do think for the future also southern Iberian Peninsula. Outside of Europe, we believe that Canada, and specifically Quebec, is one of the best places in the world. We also have now, with Inflation Reduction Act coming in the US, it makes it quite attractive to do the same in certain parts of the US, and then you have Brazil.
So what's the timeline here?
So it takes time to do what we do. Our first project then in Boden in northern Sweden, close to the Arctic Circle, it's being built as we speak. We actually erected the first steel a couple of weeks ago, and that's a huge milestone for a big construction project. So we are aiming to start to commission the plant in 2025 with commercial orders coming in very early in 2026. For our other plants, it's highly dependent, I would say, on political support and when we can get access to the grid. It all comes down to power, no project. That's really how it is. So it's hard to say which one will come after, but all of the four that I explained, in addition to Boden, the target is to have started production before 2030.
This is a very impressive timeline, I'd say. And I know that your order books are fairly full already in the Boden project, which is also fascinating. Of course, that tells a story about, how we're going to run this further and the success story that you're probably going to be facing in this project. So Valentin, turning back to Schneider Electric here, you are focused on Sweden, but you also have, of course, the overall global perspective on decarbonization here. So what is your point of view when it comes to being able to support companies in their decarbonization journey?
Yes, so thank you. So actually from Schneider Electric, we see mostly like two axes that we are really advocating for and supporting companies with. First one will be electrification, and the second one will be digitization. So electrification for decarbonization, as we talked about just like as an example for the steel industry, and digitization for efficiency. And in fact, we are kind of combining the two, and why it's kind of very relevant and interesting for Sweden as well. If you look at the pace of electrification in Sweden versus the rest of the world is kind of faster. It's about twice faster what we see in the coming decades versus the rest of the world. And globally, I mean, we are electrifying everywhere. And also in terms of digitization, you have, let's say, the two aspects of digitization for efficiency across the society, but also Sweden being a hub for digitization with a lot of data centers and a lot of data infrastructure that is being invested there also for the similar need as we talked about with green and cheap electricity and energy access, basically. So that's how we are kind of supporting different organizations with technologies for both electrification and digitization. On the electrification side, what I would maybe add is that there is two aspects that we can think of, and very often we think only about the supply side of it, like how will we produce this electricity, and a lot of debate around which way to produce this decarbonized electricity with more nuclear, with more renewables, and so on and so forth. But there is also a second aspect, which is how we, on the demand side, how do we consume this electricity and how do we make it efficient? Because that's also a way to actually enable some capacity complementary to the new, let's say, supply that we are getting. And we are really trying to work on these two axes, on supporting the electrification on both the supply and the demand side, and on the demand side really adding not only electrifying the usage, with EVs, with heat pumps, with hydrogen, which at the end of the day is very much power as well, electricity, to generate it, but also to reduce the demand of energy and electricity in the first place. So that will be how we are supporting different businesses.
Well, thank you very much. It's very interesting to hear your different focuses, but they're basically the same focus. We need to decarbonize, and we need to do it quickly. And of course, collaboration is key. It sounds like you both are on that path too. That this is what makes it happen. So thank you very much for joining us here on We Don't Have Time, and best of luck with your important work. Thank you. Thank you. Thank you.